Dear students, this is Venkateshwarlu, Senior Maths Faculty. Today we have to discuss about that 10th class 3rd chapter polynomials. So before explaining this, we have to discuss about that what is a term, algebraic expression, and then polynomial. Okay, I will explain that points wise, step by step. Okay, polynomials. Polynomials. Yeah, first introduction. So in this first point is, you know that what is constants and variables. Constants means those numbers which have a fixed value. Those letters which have a fixed value, we can't change that any other, we can't replace it by any other values. They are called as constants. For example, 1, 2, 3, minus 1, 2 by 3, 4 by 5, etc. So these and all are constants. And then variables. So what is meant by variable? A letter which does not have a fixed value. We can replace it by any other value in that place. That type of letters we call it as variables, like A, B, C, and so on, X, Y, Z. So these and all are variables. Constants and then variables. So after then we have to know that what is meant by term. So term means either a variable or a constant, or the product of variable and constant is nothing but a term. So before explaining this chapter, you have to know all these points. So that's why I have to explain that term. What is meant by term? A term is a variable or a constant, or the product of variable and constant is nothing but a term. Okay, A is the term, and even 2 also term. 2a is the term. So 3xyz is the terms. These and all are terms. Why? Because it's either a variable or a constant, or the product of variable and constant is called a term. Okay, next algebraic expression. So what is meant by algebraic expression? If two or more terms have to combine by using either plus or minus or both, then what the formed expression is nothing but algebraic expression. Okay, here I use some terms. I combine the terms by using plus or minus or even both. And then what the formed expression is nothing but algebraic expression. Example, 2x is a term, plus 3y is a term, minus 4 is also a term. I combine these terms by using plus or minus. Then what the formed expression is nothing but algebraic expression. One more example, 3 by 2 x square, 4 by 3 xy plus 3 by 2 y square minus 8. Okay, so this expression we call it as algebraic expression. Why? Because these and all are terms. I combine all these terms by using plus or minus sign. Then what the formed expression is nothing but algebraic expression. Okay, next polynomial. So what is a polynomial? So you know that algebraic expression, when we say that any algebraic expression is a polynomial, the power of in any algebraic expression, which the power of the variable is a non-negative integer. Okay, so first I taken that an algebraic expression then when we say that that particular expression is a polynomial means we have to see that power of the variable. The power of the variable is a non-negative integer, so we can say that expression is a polynomial. Okay, I will give some examples. 2x power 5 plus 3x square minus 8x plus 5. So first I have to see this is the algebraic expression. Why? Because these and all are terms, I combine these terms by using plus or minus sign. So is an algebraic expression. Now I have to verify that is it a polynomial or not. I have to see the power of the variable. So these and all are coefficients. Here what that 2, 3, minus 8 and 5 are the coefficients. Just I have to see that power of the variable. When we see that power of the variable, which is a non-negative integer, then we can say that expression is a polynomial. Of course it is a polynomial. Is a polynomial. Why? Because the power of the variable in the first term is 5, the power of the variable in the second term is 2, and the power of the variable in the third term is 1. The power of the variable in the last term is 0. There is no variable means we have to think 0. All are non-negative integers. You know that non-negative integers. Integers means is a 0, right side positive values, the set of positives, negatives, and including 0 we call it as integers, right? Non-negative integers means those integers which does not have any negative sign. From 0 onwards we call it as non-negative integers. And this power of the variable, when we say that expression is an algebraic expression is a polynomial means the power of the variable should be a non-negative integer, then only we can say that is a polynomial. Okay, is the example. And now second example, 2x cubed. Of course it is a polynomial. I have to see that power of the variable. The power of the variable in this expression is a non-negative integer, so that's why it is a polynomial. Polynomial. Now third example, 1 by x minus 1 is not a polynomial. Not a polynomial. We call it as multinomial. This one as multinomial. You have to note that point. Okay, afterwards I will explain you. Is a multinomial. We call it as multinomial. Multinomial. All the multinomials may not be polynomial, but all the polynomials may be multinomial, but all the multinomials may not be polynomials. So is the example of multinomial which is not a polynomial. Why? Because here by seeing that expression which is in the denominator position, okay, if it comes to numerator position, the power of the variable will becomes as negative. So that's why it is not a polynomial. We call it as multinomial. Multinomial which is not a polynomial. So I hope you understand. Afterwards I will explain you. Okay, next one more example. 4z square plus 1 by 7. 4z square plus 1 by 7. Of course it is an algebraic expression. I have to see that power of the variable in each term. If the power of the variable is a non-negative integer, then we can say that it is a polynomial. Okay, is the term, and this one also a term, so that's why it is a polynomial. And next I have to verify that is an algebraic expression. Next I have to verify that is it a polynomial or not. I have to see that power of the variable z square. Here variable is z. By seeing that power of the variable in the first term is 2 and this one is last term which is not combined with any literal. This term we call it as constant term. In the first example 5 is the constant term. Now in this expression 1 by 7 is the constant term. There is no variable. If there is no variable means we have to think its power is 0, z power 0. The power of the variable in the first term is 2 and the last term is 0, which are non-negative integers. So that's why it is a polynomial. Is a polynomial. So I hope you understand this concept. So after polynomial, you have to know that a degree of the polynomial. Degree of a polynomial. Degree of a polynomial. So what is meant by degree of polynomial? When we taken that power of each term, the degree of each term, the highest power of the variable in that given expression is nothing but degree of the polynomial. Okay, so I will give some examples. 2x square plus 3x minus 1 by 2. Of course, it is an algebraic expression and it is also a polynomial. Now I have to find its degree. So how to get its degree? I have to take in that the degree of each term. After them, you have to choose that after the degrees, which is the greatest one, the greatest of among the degrees of each term. We call it as, we taken as the degree of that given polynomial. Okay, when I have to see that the degree of first term is 2, is the power of the variable, not 2. This one is coefficient. The power of the variable in the first term is 2. So that's why the degree of first term is 2. And the degree of the second term is 1. And the last term is the constant. There is no variable. We have to think its degree is 0. Okay, I wrote that degree of each term of that given expression 2, 1 and 0. So among them the greatest one is 2. So we conclude that therefore the degree of given polynomial is 2. So I hope you understand this. Okay, I will give one more example to you. The second example, 7u square minus 3 by 2 u power 4 plus 4u square minus 8. Of course, it is a polynomial. How can we say that polynomial is the expression, algebraic expression, these and all terms? I combine all these terms by using plus or minus sign, then what the formed expression is nothing but algebraic expression. So in this expression, by seeing that power of the variable, which is a non-negative integer, so that's why it is a polynomial. Next, I have to find that what is the degree, what is its degree. The degree of each term, the degree of each term of the given expression, the degree of each term of the given expression is 6. I mean degree of the first term 6, degree of second term is 4, and the degree of third term is 2. The last term is constant, which is not combined with any literal. So its degree is 0 and 0, right? 6, 4, 2 and 0. Among them the greatest one is 6. So therefore the degree of given polynomial is 6. Okay, I hope you understand this. So according to degree, we have to classify the polynomials into different types. Okay, I will explain in tabular form. Okay, degree of polynomials according to its degree. So based on the degree, types of polynomials. These are types of polynomials according to its degree. Types of polynomials. What are the types of polynomials we have according to degree? Okay, first one is a serial number. I will give in tabular form, right? Okay, name of the polynomial, and next degree of polynomial, and then examples. So examples are standard form, is the standard form. I will give either example or the standard form of that polynomial. Okay, right, that first one is zero polynomial. So what is meant by zero polynomial? So already in 9th class you know that a polynomial which all of its coefficients are zeros. So when you take any polynomial, for example, here I taken a polynomial 7 u power 6 minus 3 by 2 u power 4 plus 4 u square minus 8. So these and all are terms. In these terms, what are the coefficients is 7, minus 3 by 2, 4 and minus 8 are the coefficients. If all of these coefficients will becomes 0, I mean in 7 place 0, minus 3 by 2 0, 4 place 0, even minus 8a place is also 0, all of its coefficients becomes 0, then this complete polynomial will becomes as 0. That type of polynomial we call it as zero polynomial. Okay, zero polynomial. Its degree is undefined. We can't define its degree. Okay, I will give one example for this. Not now, afterwards I will explain you. Right, next example is 0 only. 0 is nothing but is the example of zero polynomial. Next, after zero polynomial, next second one is constant polynomial. So what is meant by constant polynomial? Only one constant, its degree is 0. So except 0, all you taken by any constant value like 1, 2, 3, minus 1 by 2, 3 by 4, root 2. So these and all are etc. These and all are examples of constant polynomial. So for this degree is the degree of constant polynomial is 0. So next one is third one, linear polynomial. So what is meant by linear? Linear means those polynomials which have the degree 1. Degree 1 గా ఉండే polynomials ని linear polynomials అని చెప్పచ్చు. For example, or we can give that standard form ax plus b. Ax plus b is the standard form of linear polynomial, is a polynomial which is in the variable x. That means x only the variable. What here I taken that ab values, they belongs to R, real values, but a not equals to 0. If a value 0, if a will becomes 0, this whole polynomial will not be a linear. So this term will becomes as 0. I think if you take that a value as 0, then this term will becomes as 0. Then you will get that only b, which is a constant. We call that polynomial as a constant, which is not be a linear. So should not take a value 0. A 0 తీసుకోకూడదు. Right. Next, fourth one is quadratic polynomial. A polynomial which have the degree 2. A polynomial which have the degree 2 is called quadratic polynomial. Okay, I will give standard form ax square plus bx plus c. Yes, of course, is the polynomial which is in the variable x. But here I use that ABC, so these are real values. They belongs to real values. You can take by real. Real means either integer, rationals, irrationals, or any values which belongs to real. But a should not be taken as 0. A should not be taken that a value 0. Okay, then that type of polynomial is quadratic polynomial. Next, fifth one is cubic polynomial. Cubic polynomial. So what is a cubic polynomial? A polynomial which have the degree 3 is called cubic polynomial. Okay, I will give standard form. Ax cubed plus bx square plus cx plus d, where a, b, c belongs to a, b, c, d or belongs to R, but a not b equals to 0. Should not take an a value 0. When you take a value 0, that cube term will not be appear. I mean the term which having the degree 3 will not be appear. So that expression will becomes quadratic. It not be a cubic, right? Next, sixth one is biquadratic. Biquadratic polynomial. So what is meant by biquadratic polynomial? A polynomial which have the degree 4 is nothing but biquadratic polynomial. Okay, I will give one example. Ax cubed plus bx square plus cx plus d. Fourth degree, no? Sorry, ma. Ax power 4 plus bx cubed plus cx square plus dx plus e, where a, b, c are belongs to 0, a not b equals to 0. Okay, this type of polynomial we call it as biquadratic polynomial. Okay, I will give that example of, I will explain that what is the concept of zero polynomial. Zero, when we say that zero polynomial means all of the terms, the polynomial which of all of its coefficients will become 0. Actually, we have to write that polynomial, standard form of polynomial which have the degree n. Okay, here I have to explain that zero polynomial. Zero polynomial. Generally, I have to write that polynomial which is in the variable x and which having that nth degree as a naught x power n plus a1 x power n minus 1 plus a2 x power of n minus 2 plus and so on plus a n minus 1 into x plus a naught. So is actually standard form of polynomial which having that nth degree. So I gave that standard forms which have some particular degree, second degree, first degree, third degree, fourth degree, like that. So those polynomials which having that nth degree, I wrote that to standard form. So in this, where a naught, a1, a2, an minus 1 and a naught. So these and all are the an, we can write that an, this not a naught, an. So these and all are coefficients. What it called? Coefficients. If all of its coefficients is equals to 0, ఈ ఎక్స్ప్రెషన్లో ఉన్న కోఎఫిషియంట్స్, నాట్ ద వేరియబుల్స్, ఆల్ ఆఫ్ ఇట్స్ కోఎఫిషియంట్స్, ఈ కోఎఫిషియంట్స్ వాల్యూస్ అన్ని జీరోకి ఈక్వల్ అయినట్లయితే, వెన్ ద కోఎఫిషియంట్స్ వాల్యూస్ ఆర్ జీరో, నౌ దిస్ పాలినామిల్ విల్ బికమ్స్ జీరో. ఆల్ ఆఫ్ ఇట్స్ టర్మ్స్ విల్ బికమ్స్ జీరో. 0 plus 0 plus 0 plus and so on 0 is nothing but 0. So I wrote that example of zero polynomial. Now you know that standard form. What here I wrote that standard form of a polynomial which having that nth degree. So I hope you understand this. Is the types of polynomials according to degree. Now we have that some types of polynomials. So based on the number of terms, according to terms, number of terms is the types of polynomials. Types of polynomials according to number of terms. So according to number of terms, what are the types of polynomials we have? First one is, okay, even similarly what I explained, that tabular form I will give that. Serial number and the number of terms, okay, name of the polynomial name of the polynomial, and one example. I will give examples only. Examples. Okay, first one is the number of terms of any polynomial which is 1, which having that 1, so that polynomial is nothing but monomial. Monomial. They are having only one term, like 2x, 3x, y, z. I didn't combine these two terms by using any sign. Okay, 2x is the term, 3x, y, z is another term, 4 by 3, a, b, c, d, okay, etc. So these and all are single terms. Of course, they are polynomials. They having only one term, so that's why it is a monomial according to number of terms. The second one is the number of terms is 2. Any expression, any polynomial which having that number of terms as 2 number of terms, then it is called binomial. In name only they will get mono means single, bi means twice. The number of terms of any polynomial is 2, then it is called binomial. Okay, 2x plus 3y. Yeah, 2x is the one term and 3y is the another term. Of course, it is a polynomial which having the two terms. So then it is called as binomial. Next, the polynomial which having that three terms is nothing but trinomial. Trinomial. Okay, I will give an example. 3x square plus 4x plus 8 is a polynomial which having that three terms, is nothing but trinomial. Okay, next fourth one is having more than three terms. More than three terms. More than three terms is nothing but multinomial. Multinomial. Okay, 3x power 5 plus 4x square minus okay plus 9x minus 9. Okay, here I use that some terms. So in this expression I have that four terms, so that's why it is a multinomial which having that more than 3 is a multinomial. Monomial, binomial, trinomial, multinomial. So already I told you, no, every polynomial will be a multinomial. Maybe a will be not, maybe a multinomial, but every multinomial may not be a polynomial. ఏంటి దాని ఎక్స్ప్లెనేషన్ అంటే నేను, సో ఎక్స్ప్రెషన్, these and all are expressions only which having that more than three terms is nothing but multinomial. Okay,